Lesson 13. The Search for Oil. First listen and then answer the following question. What do oilmen want to achieve as soon as they strike oil? The deepest holes of all are made for oil, and they go down to as much as 25,000 feet. But we do not need to send men down to get the oil out, as we must with other mineral deposits. The holes are only borings, less than a foot in diameter. My particular experience is largely in oil, and the search for oil has done more to improve deep drilling than any other mining activity. When it has been decided where we are going to drill, we put up at the surface an oil derrick. It has to be tall because it is like a giant block and tackle, and we have to lower into the ground and haul out of the ground great lengths of drill pipe, which are rotated by an engine at the top and are fitted with a cutting bit at the bottom. The geologist needs to know what rocks the drill has reached. So every so often a sample is obtained with a coring bit. It cuts a clean cylinder of rock, from which can be seen the strata the drill has been cutting through. Once we get down to the oil, it usually flows to the surface because great pressure, either from gas or water, is pushing it. This pressure must be under control, and we control it by means of the mud which we circulate down the drill pipe. We endeavor to avoid the old romantic idea of a gusher, which wastes oil and gas. We want it to stay down the hole until we can lead it off in a controlled manner. T.F. Gaskell, The Search for the Earth's Minerals from Discovery.
Lesson 14. The Butterfly Effect. First listen and then answer the following question. Why do small errors make it impossible to predict the weather system with a high degree of accuracy? Beyond 2 or 3 days, the world's best weather forecasts are speculative, and beyond 6 or 7, they are worthless. The butterfly effect is the reason. For small pieces of weather, and to a global forecaster, small can mean thunderstorms and blizzards, any prediction deteriorates rapidly. Errors and uncertainties multiply, cascading upward through a chain of turbulent features, from dust devils and squalls up to continent-size eddies that only satellites can see. The modern weather models work with a grid of points of the order of 60 miles apart, and even so, some starting data has to be guessed, since ground stations and satellites cannot see everywhere. But suppose the Earth could be covered with sensors spaced 1 foot apart, rising at 1 foot intervals all the way to the top of the atmosphere. Suppose every sensor gives perfectly accurate readings of temperature, pressure, humidity, and any other quantity a meteorologist would want. Precisely at noon, an infinitely powerful computer takes all the data and calculates what will happen at each point at 12:01, then 12:02, then 12:03. The computer will still be unable to predict whether Princeton, New Jersey will have sun or rain on a day 1 month away. At noon, the spaces between the sensors will hide fluctuations that the computer will not know about, tiny deviations from the average. By 12:01, those fluctuations will already have created small errors 1 foot away. Soon the errors will have multiplied to the 10-foot scale, and so on up to the size of the globe. James Gleick, Chaos.
Lesson 15. Secrecy in Industry. First listen and then answer the following question. Why is secrecy particularly important in the chemical industries? Two factors weigh heavily against the effectiveness of scientific research in industry. One is the general atmosphere of secrecy in which it is carried out. The other, the lack of freedom of the individual research worker. Insofar as any inquiry is a secret one, it naturally limits all those engaged in carrying it out from effective contact with their fellow scientists, either in other countries or in universities, or even, often enough, in other departments of the same firm. The degree of secrecy naturally varies considerably. Some of the bigger firms are engaged in researches which are of such general and fundamental nature that it is a positive advantage to them not to keep them secret. Yet a great many processes depending on such research are sought for with complete secrecy until the stage at which patents can be taken out. Even more processes are never patented at all, but kept as secret processes. This applies particularly to chemical industries, where chance discoveries play a much larger part than they do in physical and mechanical industries. Sometimes, the secrecy goes to such an extent that the whole nature of the research cannot be mentioned. Many firms, for instance, have great difficulty in obtaining technical or scientific books from libraries because they are unwilling to have their names entered as having taken out such and such a book, for fear the agents of other firms should be able to trace the kind of research they are likely to be undertaking. J.D. Bernal, The Social Function of Science.
Lesson 16, The Modern City. First listen and then answer the following question. What is the author's main argument about the modern city? In the organization of industrial life, the influence of the factory upon the physiological and mental state of the workers has been completely neglected. Modern industry is based on the conception of the maximum production at lowest cost, in order that an individual or a group of individuals may earn as much money as possible. It has expanded without any idea of the true nature of the human beings who run the machines, and without giving any consideration to the effects produced on the individuals and on their descendants by the artificial mode of existence imposed by the factory. The great cities have been built with no regard for us. The shape and dimensions of the skyscrapers depend entirely on the necessity of obtaining the maximum income per square foot of ground, and of offering to the tenants offices and apartments that please them. This caused the construction of gigantic buildings where two large masses of human beings are crowded together. Civilized men like such a way of living. While they enjoy the comfort and banal luxury of their dwelling, they do not realize that they are deprived of the necessities of life. The modern city consists of monstrous edifices and of dark, narrow streets full of petrol fumes and toxic gases, torn by the noise of the taxicabs, lorries, and buses, and thronged ceaselessly by great crowds. Obviously, it has not been planned for the good of its inhabitants. Alexis Carrel, Man, the Unknown.